Ziobi, go ahead.
Hey, I had a theoretical question I've been sort of pondering. I was curious if there's me too, Optimus being like not necessarily in the factory, but in unstructured environments, and what people think about that.
Sorry, what's the question? If there's a danger to having options in unstructured environments?
If there's like merit to the argument that Optimus would be more suited to unstructured environments, or even I guess unstructured environments is not clear, I guess, but I feel like the factory is a clearly structured environment. Whereas if you're working at, I guess, McDonald's and you're picking up, I mean, it's somewhat structured. It's not a great example. Um, I think there's a difference between the factory floor and, I guess, the real world, where it's a lot more unstructured. So I'm curious if and there's merit to that sort of line of thinking with Optimus.
I mean, I think they have to have it in the factory first to test it out and develop it, right?
I entirely agree. I just made a post today that was like, Optimus is going to grow up in the factory floor, but then the real value comes when it's sort of released into the world and it's like taking over a Subway or whatever, fast food or elderly care or child care, whatever that is. I just termed it blue collar work.
When do you think that's going to happen?
I think cost is the real factor. I was really shocked to hear that Musk sort of puts it around like a 20,000 price range. Imagine it was like 200,000 and only but really wealthy people could have a humanoid robot. It is sort of that's the real factor. So in terms of time, I'd say like 2 to 3 years, you'd start seeing it at Wendy's or whatever.
Yeah, 2 to 3 years at Wendy's. Interesting. I guess we'll, let me see if I want a coffee bet with you. But give me 1 second. I need to get off Wi-Fi for my phone real quick. Can you guys hear me? Zeba, go ahead.
I mean, I just pulled out of my butt 2 to 3 years. So like if we're gonna make a coffee bet or whatever it is, like 2 to 3 years would be April in 2026 or late or May 2026. So I think that's pretty reasonable. With the rate of progression, and then I mean, in 2 years, if we think robotaxi is going to be like, if the timeline for robotaxi is, I don't think it's August, but if it's like around a year or so, 2 years, we'll say 2 years for Optimus. I think that's somewhat reasonable. It's all speculation, which is I'll be
Okay.
direct.
Well, let me think about that. Okay, Nick, how are you?
Good. How you doing, Yaman?
Good. What's your question?
Hey, I wanted to dig into the 10Q a little bit. You got time for that?
Yeah, let's go.
All right, let's do it. So I wanted to see about some of the deferred revenue. So there's been a bunch of talk where there's a lot of deferred revenue in energy and storage, and just wanted to kind of learn more about this space on the 10Q and educate myself some more.
Okay, I have it open right here.
Okay, so energy storage in the 10Q, it looks like, and again, this is your expertise. I'm not an expert here. I'm just trying to learn. You have March 31st, 2024, 1.78 billion that is deferred, and it looks like 417 million was recognized in December, in March 31st. So am I understanding that correct?
Yeah, in the quarter ended March 31st, Q1, in Q1 for energy, Tesla recognized $417 million of revenue. And the remaining balance of that deferred revenue account for energy as of March 31 is 1.78 billion.
Okay. And then, so that 1.78 billion is the backlog of orders. Is that, am I understanding that correctly?
Hold on one second. We have an account executive that can speak. Let's see. Yeah, multiple requests to speak is an automatic removal from the space when I rejected your request. So you can listen to the recording. So what do you mean by backlog?
Or think of it like, I don't know if they only recognize maybe like 50% or 75% up until it's turned on, or do they recognize 0% until it's turned on?
So my
I guess-
understanding from based on what I've seen over the last couple of years from others' posts and stuff is that there, and this makes sense, there are milestones to recognize portions of the contracted revenue. So if you're, my understanding is the following, okay? If you are a potential customer and I'm Tesla Energy, all right? And you come to me and say, I want to order $1 billion of megapacks. $1 billion of megapacks, okay? There are multiple milestones that we work into our contracts. So it can be something like step 1, when the contract is first signed. Step 2, when the megapacks are produced. Step 3, when they are shipped to your location. And then step 4, when they're installed and connected to the grid. Okay. So based on those steps that I'm just kind of for illustrative purposes laying out for you, I get to recognize a quarter of the revenue because we laid out 4 milestones. Okay. Contracted revenue each time I reach one of those milestones. So in our case, contracted revenue is $1 billion. And when we sign, I get to recognize a quarter, so $250 million. When I produce them, I get to recognize another $250 million. When I ship them to you, I get to recognize another $250 million. And then when I connect them and connect them to the grid, install them and connect them to the grid, I get to recognize the last $250 million. Okay. So in that way, this is called project completion of project method. I think. Hold on, let's make sure.
Got it. Yes, this is like in my line of business with vertical transportation. This is like we did the same kind of deferred revenue.
This is called percentage of completion method. Percentage of completion method. Okay.
Okay, understood.
Yeah.
So that means that there's only 1.78 billion in the backlog, and the revenue that they performed in the energy sector for this quarter was, let me see. I just wanted to put it into perspective. Energy and storage did 1.2 billion in quarter 1. So that's about a quarter and a half work of backlog in the deferred revenue. Am I understanding that correctly?
Yeah, it seems from, I mean, another, like, I think a better way to word that is, and it seems like an average contract length is like a year. Okay, so if you come to me, it looks like on average from those numbers alone, on average, it should take about a year to recognize the revenue. Okay. So, like, there's no huge windfall that's about to, get to the income statement that people are kind of hoping for. There's none of that. This is just normal accounting for a project that lasts more than a quarter. And it has clear milestones. And there's accounting methods for it So this is very regular, normal stuff. And the way I kind of look at it is, I look at the storage deployed on the quarterly presentations, and then I look at the Tesla energy gross margins. And that's really the all two numbers, the two key numbers I need to value the Tesla energy business. This obsession about percentage of completion method and the cash flows every quarter is just kind of misses the point, I think, and wastes too much time on stuff that doesn't matter.
Sure. Yeah, and now I understand why you say it that way, because the only way that this could possibly matter too, like in another form, is if like the final completion of the project, say for example, they recognized all the costs in the first three segments, and the last segment for whatever reason is all margin. That's where maybe a little bit more windfall could be, where all that is all margin as opposed to and they
No,
used up all the
that's not
costs. So
that's not true. Not true. Because you have to match the revenue and the costs. So it's not like you're recognizing all the revenue cost first and then all the revenue later. It's not like that.
yeah, you match it together. So I used to do this in my line of business now, but you go off of an estimate. So it's all based off of estimate and actual cost, but you base it off of the estimate, and the estimate, if that was fluffed up, because like these were just starting to roll out, for example, um, they could be sitting on a lot of margin.
Do you think that's the case though?
Not. I have no reason to believe that. I'm just saying that's a possibility. Like that could be like the only windfall that everyone's really excited about. Now there is something else. If you keep reading on that other line, that there is more. There's a 3.86 billion. So let me read this real quick. So it says, as of March 31st, total transaction price allocated to performance obligations that were unsatisfied or partly unsatisfied for contracts with an original expected length of more than 1 year was 3.86 billion. This amount we expect to recognize 1 billion in the next 12 months, and the rest over the remaining performance obligation period. I don't understand what that means.
That means there are some contracts that are lasting more than is expected to last more than the year.
Okay, so
they're multi-year contracts.
Okay, and so this 3.86 billion, does that have anything to do with that 1.78 billion, or is this totally?
Hold on for 1 second.
Okay, you're 1 second up, Jan.
Okay.
That was 8 seconds. You owe me 7 seconds.
Well, go ahead. Does that make sense? They're multi-year contracts.
Yeah. Okay. So is that just to better understand it? So is that 3.86 billion? Is that the backlog work that they have, and the 1.78 billion, like maybe it's work in progress?
They're the same account. The hold on 1 second. Okay, I see the difference here. So in the first sentence, it says non-refundable amounts. In the second one, it says performance obligations. So think of the first amount as, deposit that if the customer cancels, they're not going to get that money back. And think of the second amount as it depends on the performance delivered by Tesla. So you have to produce it, install it, connect it, and then you get that cash, or you earn that cash. So that's a refundable amount.
Okay, got it. And is that 3.86 billion? Is that where can we see that amount? Is
That's
that
still in the same account, the deferred revenue account.
Okay, got it. Okay, yeah, I mean that was like one of my big questions because like
yeah, because the total amount is 3.0 plus 3.2, 6.2 billion. And then if you go down to FSD, 3.5. Okay, and then if you go down to energy, that amount is 3.86. So that adds up to 7.3. But then you also have to include the 1.78. So you're looking at about 9. Yeah, there might be some off balance sheet here. There has to be. Go back to the balance sheet. 3.3. So deferred revenue accounts add up to 6.2 billion. Let me just look at the FSD one, the automotive sales one real quick. Deferred revenue related to access to FSD capable of features on the maintenance different blah, blah, amounted to 3.5 as of March 31. Okay. Deferred revenue is equal to transition performance of the unsatisfied revenue recognized on deferred revenue balances. That's the income statement amounts, 281. All of the deferred revenue we expect to recognize. That's the forward-looking statement. We record, on the energy generation, we record deferred revenue, non-refundable amounts. And those are 1.78 as of March 31. And then revenue recognized, those are income statement amounts. And then total transaction allocated profit obligation on sales department is like 3.86, more than 1 year. 3.86. So energy amounts add up to 5.5. Yeah, it all adds up to more than what's recognized, what's shown on the balance sheet, slightly more.
Yeah, that's interesting.
Yeah. So that means they haven't collected the cash, or so contractual amounts. Does that answer your question?
Yeah. So then, yeah, just to reiterate your statement, if I say it correctly, or maybe this is my own statement, the energy business doesn't have that much in the backlog that people are saying. It's just normally growing exponentially, but there's nothing waiting for in the backlog, like not significant.
I mean, there are billions waiting in the backlog. But okay, so let's do this. So let's say back to our $1 billion contract between you and me. I'm Tesla Energy and you're the customer. And we signed a $1 billion backlog. Okay. And let's say milestone 1 is contract signing, which means you pay me $250 million and I get to recognize that $250 million immediately on my income statement. So there's no deferred revenue on the balance sheet. I immediately collect the cash and recognize it on my income statement. So it shows up as revenue. I recognize the estimated costs associated with that first milestone and recognize on the income statement as COGS on the Tesla Energy. Okay. You also give me the second milestone payment, let's say, another $250 million, the second $250 million. And that depends on me producing the mega pack. And I haven't yet produced it, right? That $250 million shows up on my balance sheet as deferred revenue, yet to be recognized. So I'm going to recognize that, meaning I'm going to bring that $250 million from balance sheet to the income statement once I produce the mega pack. So that depends on me achieving that milestone. That shows up as deferred revenue. Okay. Let's say that you haven't paid me for the third or fourth milestones, the third and fourth $250 million. Those $250 million don't even show up on the balance sheet as deferred revenue. They show up in that note that says, you're going to pay me that amount, like that 3.86 billion or whatever it was. Those two payments, because we already signed, right? So the contractual payments, they would show up as kind of like another bucket. But at the end of the day, what really matters is Tesla producing these mega packs, because we know demand for these mega packs is way more than production capacity anyway, right? So let's say, for example, take all the numbers that we see on the 10Q, and let's change that 3.86 billion. That's kind of like more than 1 year out, contractual, etc. Make that 10 billion. That changes nothing about my estimate of the value of Tesla Energy, because we already know this is a production limited or interconnect limited business. It just says that we just signed more contracts. But whether that happened today or 6 months or a year from now doesn't change anything about the future cash flows. So why focus on that number, right?
Right, understood. So if I understand you correctly, another way you could think of that 3.86 and 1.78, so roughly 5.5 billion, is that's the current backlog that they're working through. Is that accurate? And if that's true, they're doing 1.5 billion a quarter right now. So that's like a year of backlog, depending on how quick they work.
Yeah, I don't know if you can say that, but I mean, basically, there's like billions of dollars, or that Tesla needs to work through, and this is a production limited business.
Okay,
That's all
cool.
I think I'm willing
Yeah,
to
thanks.
say.
Thanks for that.
All right. Maybe if Wes can come up, we can talk about some of these FSD posts I replied to. How is FSD doing for you, Nick?
Yeah, it's doing well. I mentioned yesterday, the highway, there was a couple issues in the HOV lane. It won't go over a solid white line. I have to push it to go over it. So that's kind of annoying. And but I mean, it's been flawless. Like Diane, my wife's amazed by it. Like it's definitely passed the wife test. City streets, only at certain times it's jerky. There's a lot of hills in Seattle, so as you're coming up or going down them, as you're going up them, it will accelerate a little bit quicker than normal. I think a little bit quicker than it needs, but I feel like that will smooth out. And then when it's coming down to a stop, it kind of slams on the brake. So those are some things that I think will smooth out as it goes, because some of the earlier versions like 10.69, had it smooth out. Yeah, I mean, I have no edge cases except for the one on the highway. When you're in an HOV lane, there's also a lane that you can go into that's separate, that can be an express lane, and it's an express lane for both ways. So at certain times, one way is closed and the other way is open, and it did not recognize some of those barriers when it's closed. So I had to disengage for that. So that's a big one that they gotta solve in the next update. But I reported it, and yeah, let the engineer.
All right, good. All right, thank you. We're gonna switch topics for a second. Anwar Beck is here, and Matt Holm is here, and they're gonna give us an update on Austin. Anwar Beck got a Cybertruck. He's getting wrapped. Anwar Beck, how are you?
Good, man. How are you guys? Get to the
I'm good.
spaces.
Tell us about your Cybertruck.
So I did pick up the Cyber Beast kind of at the very end of quarter. Had a really amazing experience because Tom Zhu, like the VP of automotive, came and like hand delivered the vehicle. A bunch of the executives came out. So I thought it'd be fun to have all of them sign the frunk. So I've got a bunch of signatures. I've still got a place for Elon and Franz and the rest of the engineering team to sign it, but I think it'll be fun.
How do you like it so far? Have you been driving it?
I think I could speak very well to the whole like dual motor versus tri-motor. Matt, who I think is on here, picked up the dual motor Cybertruck pretty early, and basically we treated it like our both of our vehicles. I chauffeured him around because it was getting to drive the Cybertruck. So drove it for a few weeks, and then when I got my Cyber Beast, I was shocked at the difference. One of my buddies is the head of motors at Tesla, and I asked him, I'm like, dude, it sounds different. Like the whirring sound in the Cyber Beast is like, it sounds super cool. And then just the performance, like that extra horsepower of the tri motor, like I feel like most people that have the dual motor, and I actually told Matt, I was like, dude, do not drive my Cyber Beast because I feel like you're gonna sell yours and try to buy the Cyber Beast immediately.
Are you smack talking my Cyber Beast? Come on, or my Cybertruck? Come on, man.
I am.
Yeah.
Have you guys raced it yet?
No, dude. I can't believe we haven't done that yet. No, we haven't.
Dude, I'll be over in 10 minutes.
Okay.
Dude, you should film that and post on X.
That's a great idea. Okay, we'll do that soon. No, Matt and I live like one street away from each other, and we're always together. So yesterday he picked me up in his Cyber Beast or Cybertruck, and then I pick him up in mine every once in a while. But the other thing,
so just for the audience, Anwar Beck and Matt swing by my coffee shop every now and then. Especially Matt, we chat every 5 minutes for 5 minutes or so every day about the real estate business in Austin, how real estate is looking. I ask him about kind of the demand and supply in Austin. And Matt, by the way, was so I'm going to talk to Matt for a little bit on our back. Matt was the person who I think has been most accurate about real estate trends because 2 years ago, I actually bet Matt a coffee or beer. I forget which one. And because he predicted, yeah, and he predicted mortgage rates would surge above 7% 2 years ago. And I was like, there's no way that's gonna happen. Like the economy would crash. And he was right. I was wrong. Matt, what kind of gave you that insight 2 years ago that I haven't seen from anybody else?
I mean, you could see they just had to cool inflation, and the biggest hammer that they had was interest rates, and the same effect for anything that touches interest rates, obviously cars and housing. So that's the effect you're seeing really with Tesla. Lack of demand is really interest rate driven. People are holding onto their cars longer because they're waiting for interest rates to go down, and their affordability has basically been cut in half. It's better deal on Teslas right now. There's downward pressure on pricing, and the same thing in housing. So it really becomes an interesting time to buy either one. At a certain point, it just sort of becomes undeniable. And in both cases, you could always refinance when rates go down. I'm guessing, and once again, I don't have a crystal ball, but I try. I would say we're going to have to wait till after the election. No matter which side wins, I think we're going to see likely something that dips into the low sixes for 30-year fixed mortgages at that point, and obviously some kind of commensurate drop in auto loans. So I think at that point, incentives go away, both probably from Elon in Teslas and most likely from sellers, because I'm negotiating some incredible deals for housing right now, just because sellers that have to sell are we're having to come to Jesus on pricing and on seller concessions, just to make it juicy enough for the buyers to say yes.
And you believe, I wanted Yutz here to kind of talk about this, because you're very bullish on the demand for housing going forward. You believe that there's a large amount of people waiting for mortgage rates to come down just a little bit, right?
Yeah, well, and that's exactly what happened. So, we've dropped a little bit on, and people, the news says, oh, Austin, people moving out, it's too expensive, etc. We had 2021, we had 80,000 people that moved here. We're down to about 60,000. That's still pretty. It's a pretty good net positive for a city our size. And typically, these people are not moving here for minimum wage jobs; they're moving here for tech jobs, and probably a third of them are going to turn into to buyers in the first 12 to 24 months. It's kind of the pattern that we see. And those buyers that moved here in 21 and were waiting to rent and then move and into something in 22, rates went up March 22, and all of a sudden it froze the market. And so we've had a bit of a frozen market as far as demand. I mean, there's just the absorption rate is down so much in housing. And so you have these buyers that have been sidelined that moved here in 21 that would have bought in 22 and didn't. 23, they sat on their hands. 24, they sat on their hands. In the meantime, housing permits are down to a quarter of what they were 2.5 years ago. We had 6,000 permits pulled for new housing just in the city proper, not MSA, for Austin, early 22. And last year we were down to 2,000. This year, I haven't seen the stats so far for first quarter, surprisingly, but I'm guessing we're down to at least that number, if not 1,500 permits. So we have a decrease of things coming online and a pent-up demand that I think will be released when we sit and hit about 5.875, maybe low sixes, and they're all going to get back in the market at the same time. And then we're actually going to see how little supply we have and how little is coming to replace it. And so, yeah.
So I asked Matt to kind of come in every few weeks or so, like once every few weeks or so, kind of give us an update on Austin real estate, because real estate is very important to inflation trends. Inflation is obviously very important to interest rates, and interest rates are very important to Tesla sales. So, and Austin is very important because it's kind of a predictor, I think, to general national trends. So Matt is going to be our real estate expert in this space once every few weeks or so. And then in the meantime, they also, both Matt and Anwarbek own Cybertrucks. Anwarbek owns Cybertruck Beast, and Matt owns a dual motor Cybertruck. So they can talk about their Cybertruck experience and kind of what people are saying when they come to check out the Cybertruck, any sort of their experience with wrapping the Cybertruck, etc.
Anytime you want to drive it again, Yaman, just let me know. And when I get FSD, it should be fun.
And Yaman,
Thank you.
just for the audience that's on here, Matt, it's kind of a legendary dude in real estate here in Austin. He's worked in real estate for over 16 years and has closed personally, not his team, but by himself, over 1,600 transactions. I joke that like when I'm talking to, he's done the most push-ups out of any real estate agent in the nation, not even in Austin. Compass is the #1 brokerage here in Austin, and Matt's the #1 agent in Austin.
All right.
So as far as
All
tip
right.
of the spear, that knows what he's talking about. Yeah.
Thanks, guys.
All right. I mean, otherwise I wouldn't invite him here anyway.
That's right.
All right. Thank you.
All right. Thanks, Yaman. We'll talk to you soon.
Thank you. All right. Bye. Wes, welcome. Wes.
Hey, thank you. Hopefully you can hear me okay. Different
Yeah.
mic.
Yeah, it's coming out perfect, actually.
Oh, great. That's good to hear.
So I want to ask you about these couple of the videos that we're seeing
Yeah,
coming
sure.
out. Let's see. So what do you think? So I'll pin at the top, FSD beta test pilot says the cat is out of the bag. 90% of my bonehead Tesla navigation FSD issues can directly be attributed to Google's depiction of lane structure. Google allows you to fix these via desktop. Simply right-click and choose report a data problem. The real question is, why is Tesla not using their millions of cars to auto-generate HD maps? What do you think about this?
Yeah, the definition of HD maps is centimeter accuracy. The NERFs that the neural radiance fields that Tesla uses to create 3D space from stitched together camera videos is not applicable to that end goal. However, that's not to say that Tesla couldn't use that data to auto update through an API Google Maps data, road segment data, like he's depicting here in this image. So that's a potential. I'm not sure that Tesla is using this though. They might be using OpenStreetMaps API, which could be different. But I still need to read through this because I'm not sure what bonehead things are actually happening.
Yeah, I asked him to come in, but I don't think the account is here right now. So if he does come in, then we can ask him more questions about it. But the reason why I brought this up is because I get a lot of questions about the map, like how much FSD relies on map data, and if it's going to decline going forward, and at some point, just rely on what it sees altogether and not even check the maps at all. But I know you have the position that Tesla will always use map hints, right?
I believe that is the way to establish a level of trust for a given upcoming road segment that would allow you to drive more like a human. So that's why I think some of what we're seeing is way more human-like than it used to be.
Have you changed your view on first commercial robotaxi ride yet, or no? Like, when do you expect it to happen? I kind of forget actually.
No,
we're
on track. I think we're on track for end of year.
First commercial ride by the end of this year.
Oh, you're saying paid ride?
Right, paid driverless ride.
With no human in the driver's seat? Or
right, driverless, yep.
Oh yeah, that's end of next year. That's what I would say.
Okay, end of next year. Got it.
End of this year is my prediction was you'd have at least a safety driver, but you'd be able to actually potentially collect money.
Okay, gotcha.
Maybe I'll say one thing if you.
Yeah, go ahead.
I think they're actually going of FSD. especially the all-up licensing, to buy a full license and keep it on your vehicle, and then the monthly cost. So I think we're now at a position where it's the collection of data, and we're talking about like this really unique clip data that they need to do the March of Nines, and scaling their model size. So scaling their model size and their architecture has largely been what he said they were going to do. So that's part of the algorithm. The other part that I think is going a lot faster now is this data collection. And I think you remember the thing that I did where it failed almost 100% of the time in this very simple left turn median maneuver. And then it downloaded all of this data, or uploaded it all to the cloud, and then downloaded what seemed to be new map data because my build never changed. And then it worked 100%, like amazing. So I wasn't actually using that in my prediction, as well as this faster data collection. So now I really, this is why I think this 8.8 presentation that they're going to do could be the beginning of a robotaxi beta with a driver's seat, with a human in the driver's seat, but they can exercise the new kind of end-to-end ride-hailing app code and pick up and drop off procedures, things like that. Thanks.
Thank you. Tesla 99T.
Yes. Yes. Hi, everyone. So can you hear me?
Yep. What's your question?
So yeah. So I live. So I live in North Texas. You can tell from my profile. So I wonder if anyone have noticed that Elon mentioned hardware 5, 6, and even 7 in the earning call.
Are you asking if Elon mentioned those things?
Yes. Yes. So I wonder if you.
But why don't you just check the transcript? Why
yeah,
are you coming up and asking a question?
Sorry, I'm not asking. I just want to share my thoughts about that. The new hardware platform and the distributed inference service.
Do you have an expertise in the area?
Yeah, sort of. So I was a engineer in TSLA AI team. I had worked there for 7 years.
Okay, go ahead.
I quit my job last year. So when I heard that Elon mentioned hardware 5, 6, 7, that's super excited, especially when Ashok. So he just described that how that will work for the distributed inference service. I think so. If I remember correctly, that hardware 4 came to market last year. So so Elon mentioned that hardware 5 will potentially be in the car by end of 2025, the end of next year. That means it takes only less than 3 years to upgrade hardware 4 to 5. And so from hardware 3 to 4, I think it's almost 5 years. So basically, it's half the time. I mean, to iterate from hardware 4 to hardware 5. So I think people may wonder that what's the reason behind that. People might say, okay, maybe Tesla run out of compute. It's not enough compute hardware for the robotaxi. So in my opinion, that's not true. I think the hardware 5 is majorly for the distributed inference service. That's the first time that mentioned by Elon Musk, by the management team. So hardware 5, I think it will, because hardware 3 and hardware 4, these two platforms are customized for full self-driving, for the video data, for the convolution neural network. But in the earning call, that Ashok said the hardware 5, the distributed inference, will be used for the documents, which means that it will run large language model. So I think that's a major reason that Tesla want to design this new hardware and put it in the car as early as 2025. I think because inference for a larger model is larger language model is huge market. If you look at the Andrew Ng post today, so he said that this people when people talking about the compute constraint, that's majorly about the training. However, in his opinion, the compute requirement for inference is underestimated. So I think it's a huge service, huge opportunity for a Tesla, that if they put hardware Wi-Fi in a car that can run larger language model distributedly for the so let's say XAI. So that is a great opportunity that I think is more prosperous than the than dojo training. Yeah. So
Okay.
that's the stuff I want to share.
Hold for 1 sec, Wes.
Say a question for you. I think it's 99. For some reason, the blue check mark is over the icon. Do you know if are you referring to just distributed inference, or are you referring to distributed training?
Only inference.
And running a single LLM on one essentially in one vehicle, is that what you're referring to?
Running a single model, but for multiple users' request at the same time.
So essentially using one vehicle, let's just call it vehicle, using one vehicle as a...
Sorry, that was a mistake. Please unmute yourself and go ahead, Wes.
Oh, sorry, I don't know how much you heard. I'll start over. Using, let's just say using one vehicle then is like a cloud service for inference, like bulk inference. Is that correct? Is that what you're referring to?
Yes, that's what I learned. I understood from the earning call. Yes.
Gotcha. And I'm wondering if you have insight into what the GPU is used for on the FSD computer board. Because there's two trip chips, but there's also a GPU. And I haven't been able to find any specifications that talks about that GPU. And I'm wondering if that has floating point 32 capability and potentially is able to run multiply add matrix matrix calculations.
I'm sorry, I couldn't comment on that. That's confidential. I couldn't.
Oh, gotcha. Sorry. I thank you for saying that. I wasn't asking for you to harm yourself in any way. I didn't know if that was public or not, but sorry for asking.
Okay, Tesla 99T. So you're saying you worked at Tesla AI for 6-7 years, right?
7 years, yeah.
But you're not willing to share your name, is that correct?
Yeah.
So did you guys hear that?
Oh, it cut out for me. I was just wondering, like, I'm maybe not sharing the name, but if, sharing potentially what was worked on, maybe more specifically, would be interesting for me so that I could ask a more pointed question.
Sorry.
Well, first of all, I need to make sure the person who is saying they worked at Tesla actually worked at Tesla. Like, I have no evidence right now that this guy actually worked at Tesla.
Yeah, but at the moment I don't want to share. But many of my AI colleagues, so they are following me. Yeah, but, so at the moment I don't want. Yeah, but if I look at my follower list, so many people from the Tesla AI team, they are following me.
Yeah, just so you know, I used to work with Ashok. Like we started the autopilot team together in 2014.
Oh, cool. Yeah, I worked from 2016 until the end of last year.
Oh, that's great. Well, thank you for your service. I'm just more interested in kind of the FSD hardware 4 board. I don't know. I don't want you to share anything that would get you in trouble, obviously. But I'm just looking for a little bit more detail because Meta and I were having a discussion yesterday about potentially using the board to do distributed training. But I'm all for distributed inference and doing bulk. I also worked in Google Cloud and product managed TPUs. So I'm very familiar with distributed inference and training.
Yeah, so I really don't think it's easy to do the distributed training on vehicle because you need a batch as an input, batch data as input, and the backward propagation is more complicated than because as far as we know that the hardware 3 it's running integer 8 precision. So I don't want to comment on hardware 4, but just want to point out that it's super hard to do integer 8 for back propagation in training.
Yeah, int 8 definitely not. 16 potentially. 32 obviously no problem.
Yes, I don't want to come so to say it couldn't do, but I just want to point out it's super hard, and because the large language model inference is a huge market, I think. So I just want to point out, because I see very few analysis on that, and I hope that people can start to do some analysis to see that how much income it could generate for Tesla.
Oh yeah, I can run those numbers. That's essentially TPUs were used for that. The single chip version of TPUs are very cost effective for inference, large batch inference. So I can run those numbers, but I mean, from my memory, like very quickly off the top of my head, a given chip could run about 1,000 inference requests about a minute. And so those can essentially run, like you can charge upwards of like $7 or $8 a minute to run that for all of those inference requests, especially if it's an LLM, because those can be pretty pricey. So the numbers can get very big very quickly.
These are very vague terms. Very big, very quickly. We have an anonymous account claiming. I mean, Wes, are you convinced that he worked at Tesla?
Not quite yet, but the data that's being given is good, and it's in line with what I'm thinking, and it's in line with what Ashok said. So I don't see.
So what's very big?
I would have to work through the numbers because I don't want to miss a zero and say something that makes no sense.
Andre?
I just wanted to ask a quick question because this is kind of really interesting. So, what is the feasibility of having Grok being trained over hardware 3 or even possibly hardware 4? Because I mean, reason for my question, right? So if we want to do some kind of, like, if a consumer wants to do some kind of extra training and so forth, instead of buying hardware, just use your Tesla at home.
Yeah, I can take that. And I'm not speaking for the other speaker. This is purely my speculation. But if I was to design hardware 4 and I was to upgrade the trip chip, I may include some package space and some real estate of the chip for a small matrix multiply that allowed for floating point 32. And then the GPU that resides on the board as well, that is also potentially floating point 32 with also, because NVIDIA's done this in the past, they've added some tensor cores to their GPU layout in their SoCs. So that I would potentially do as well because it's very, very cost effective. And it shouldn't, it shouldn't add a lot of cost to the board. Then you have the flexibility and the optionality of potentially running training, very, very small matrix multiply. And if you were to harvest this out and then you had a very low latent way to connect these together. I mean, I'm not saying that you could be super efficient with your energy use, but this distributedness of this over millions of vehicles potentially, and they just sit there for hours, and they could do this, and you could, like save off, your state at some point and then pick it up later. Like distributed training becomes viable at that point. Distributed inference is a done deal. Like the ability to do that in batch and in bulk is not hard, based on if you already have an inference kind of optimized chip. You know about how much it can handle. You can send this data over to it. It reliably comes back. The state of that chip is not going to change in this amount of time. I mean, this is essentially what cloud providers do with their idle time, and they sell. AWS calls them spot instance. I don't know if there's any developers in the audience, but these are like the really low cost inference nodes that they have, or even just compute nodes. And then I can't remember what cloud calls them. It's like interruptible or something nodes, but it's the same concept.
Interesting.
What's an example of, like, just in plain English, what's an example of a task that Tesla can do using the distributed inference compute power on its millions of cars?
Yeah, so let me give you an example of my phone. So I have a Pixel 8, and let's say that I disconnect it from the internet, no cellular, no Wi-Fi, and I ask it with my voice, what time is it? It will know the answer because it has an edge TPU inside of it, and it's running a language model natively without any connection to the internet. It knows what I'm saying. It turns that into something that it can act on inside of that chip. So that's inference. It's running inference locally. So an example for a vehicle, kind of like the speaker was pointing out, but I see that they're gone. You could use the vehicle while it's sleeping, or even potentially being driven around if it's got extra compute. But let's just assume that it's sleeping. You could send it a batch of 100 LLM requests, like, various people are running queries, and that all gets batched up into one request. It gets sent to the vehicle. The vehicle responds within 2 or 3 seconds, and then it's sent back to the user, and it's all spit out. And that's free compute, right? That's free inference, which normally cloud providers charge for. And now Tesla becomes a cloud provider of inference, LLM inference. So the example that I think that everybody knows is ChatGPT currently charges a monthly rate for this, to access ChatGPT 4. And that's what Grok would be. That's where Grok could run. In other words, XAI would need to not invest in any inference cloud, because their inference cloud would be Tesla vehicles. Does that make sense?
Yeah, I got you.
Okay.
So then XAI would pay Tesla for using compute, just like
yes,
OpenAI, pays Microsoft, or
exactly. Yep.
Right.
Yep.
Well, I feel even more than that. I mean, I can't off the top of my head name exactly the scenarios now, but it feels like it's coming with more and more AI integration into our everyday lives. You would imagine that I would have easier time trusting the fact that I'll let my phone just listen into me or to my house or whatever, as long as the only thing that processes it would be the Tesla, right, sitting in the garage. That way, at least any training, any information speaking or whatever, so I can always recall a conversation or something. It feels this is kind of maybe not the exact scenario, but it feels like as we get more and more AI integrated into our lives, having an ability to both train and do inference is extremely valuable, and most people won't have the
what's extremely valuable?
Compute for it.
That is a vague term. What is extremely valuable?
It's a great question. That's the thing. So I'm hypothesizing on the possibility of the value they're coming in. Obviously, I can't name it, but it's just given if you look at it, where everything's moving, there's more and more demand for AI inference and AI training.
All right,
And
thank you.
privacy-based.
Akshay,
I was cutting in and out when the earlier speaker was saying who said they were from Tesla, but can maybe Wes or you TLDR what he was saying about the adequacy of hardware 3 for being able to run not like somebody else's cloud inference or anything, but just the FSD inference model that could get pretty big by the time we get to FSD. Did any
Wes?
So just to be clear, are you asking me to kind of summarize what the other speaker was saying?
Yeah, I felt like he was saying something about it, but I was kept cutting out. I couldn't quite
Got it.
hear.
Okay, so my very, very high level, very quick takeaway.
In one sentence, he said, I worked for Tesla for 6-7 years, provided no evidence. There's a bunch of people in the replies that says he did work at Tesla. And all he said was it can do some inference. The computer in the cars can do some inference. That's all he said.
My specific takeaway is that he agreed with Ashok and said bulk LLM inference. That's the key. And the reason,
but nobody is questioning Ashok.
I
That's
know.
not where the weak point is. So what is the value of an anonymous account coming in and saying, I agree with Ashok? There's no value added from that interaction. The question is, what is the potential of this?
That's why I asked.
And everybody is talking about extremely valuable, very big, but nobody's willing to put numbers around it.
No, I literally meant just the FSD inference, not even this whole cloud thing, because I haven't even wrapped my head around.
Yeah, we're talking about the cloud thing right now, because nobody's questioning right now that you can't run an FSD model in these FSD computers in the cars already. We're talking about the distributed cloud service, like an AWS.
That was the part that I was questioning. I'm not sure because the model is likely to get bigger. I didn't hear what he was saying about the size of hardware 3 in regards to what it might be able to run in the future. This whole inference into the cloud and all this stuff is even for me like a little further away.
Okay, well, we're talking about that right now. So then you should be on the speaker board if you don't have a question around that.
He made. Can I say what I think he said?
No, you have to raise your hand and wait on mute, and wait until I call on you. Like, people are acting like this is the first time they're coming up the speaker board. This is ridiculous. Wes, are you willing to put any numbers around the inference compute potential that using the computers in the millions of Teslas?
Yeah, let me put together what I think its cloud earnings potential could be for a single car per hour.
Okay. Oh, you can do it speaking out loud if you want.
Yeah, I need to look up. Let me look up the AWS inference optimized spot instance because I need that number, and then I need to look up a figure of how big of an LLM can it run because I don't know the memory size, and then what its bulk output could be in terms of like thousands of requests per second or thousands of requests per minute handling. So I need that figure. And then I would also need the response time. How quick can it ingress and egress that data? And then I have to figure out the cost of all of that. And then kind of times it by, however many minutes we want to talk about and see what the earnings potential could be. At least that's my thought process. That's what I need to do.
I mean, so let me ask you this. So I really want to approach this from like plain English perspective.
Yeah.
Okay. Because the reason why is because I don't doubt the rest of it. Okay. Like I don't doubt your technical expertise or Ashok's technical expertise or the intentions or anything of that sort.
Yeah.
But we really need to kind of like plain English potential.
Okay.
Okay. So first of all, what can I use it for? Like, why would I ask the car's computer to do inference as opposed to going on my phone or going on, on ChatGPT or, Grok on the internet? Why would I ask the car to do inference?
Like, just to be clear, this is 100 or 1,000 different people using your car to do their inference. Their LLM.
Okay. So this is very similar to then Powerwall connecting to a virtual VPP, virtual power plant.
You got it.
Similarly, my FSD computer in the cars will connect to some sort of a distributed inference service, and in return,
Exactly.
the owner of the car will maybe get a credit to their monthly payment towards the car. Is that it? Or a monthly subscription?
Yeah, you got it. Yep.
Okay.
I'm going to hire you as a tech product manager now.
Yeah, done. Or you can just, I'm sure you do. I mean, you do a lot already, but I was gonna say Patreon, but you already do a lot. Wait,
no, but it's very similar to VPP. Yeah. So just anticipate that this is going to happen at some point, because this is not hard.
But here's the thing, though. So here's the thing from an investor's perspective, right? VPP is already happening.
Yeah.
And it's not being valued. So why are we talking about something that's potentially years down the line that might happen? So tell me why this is more valuable, and it will definitely be more valuable than Powerwall VPP.
Grok would be the customer. And currently, when you use Grok, it accesses an inference optimized cloud API. If that was the vehicle, they just need to point that at the vehicle, right? And they just set that API for the vehicle up as a distributed inference, bulk handling machine, and it's distributed across all the idle vehicles. So, I mean, I can go through this from a technical perspective, like how I would orchestrate that, but it's not hard. Like, you could even probably get
like I understand. Again, the technical aspect of it, I trust you.
Yeah.
Because and if I need to understand, I just first have to understand the opportunity.
Right. I get
what is the opportunity? Like, even if it's easy, why should we do it? Why would Tesla do it? Why is Tesla better positioned to do it than the next guy? Like, those are the first fundamental steps before we even get the technical of it.
I think about the cost of Grok's inference data center or cloud service cost. And I'm sure their cost is somewhere in like, $10 million a month or something to access all of that inference compute, to give you an idea, just ballpark.
Mm-hmm.
Somewhere in that range, right? It's not $1 billion a month, and it's not $1 million. It's somewhere in the $10 million a month range, I would think, or maybe even as high as 50, to handle all of those requests.
The other way to kind of, I think, pitch this is similar to how Apple pitches it. We do this locally on your phone, they say. So your privacy stays on your phone. And Tesla can say similarly, we don't need to access the cloud, right? We can do the inference job on the car. Is that legit?
Yeah, totally. They could say that. Yep.
So then the question is, why would I do my inference job on the car as opposed to my phone?
You probably wouldn't. The phone's going to be more efficient.
Okay. So then FSD computer is mostly used for FSD, even years down the line. Is that correct?
What is more efficient is if you use it as a cloud inference API, because then you could do thousands of requests at the same time. Then
okay, so then this distributed inference compute would be competing with Microsoft Azure, Amazon AWS. Is that true?
That is true. 100%. Yes.
Okay. But okay, then the next question is, that business appears to be race to the bottom. Microsoft Azure is eating into Amazon AWS market share, and profit margins are declining, and revenue growth has slowed down for all of those services. So why is it valuable to Tesla?
Because they handle it soup to nuts. They create the API, they manage it, they can optimize it. The cost is, I would think, would be the lowest it could possibly be. They don't have to rely on AWS either.
Okay, so you're saying Tesla would do this more efficiently than AWS?
Over time, yes.
And why is that exactly?
The data centers that AWS run are not all optimized for inference. They only have certain nodes that are optimized for that. However, if Tesla optimized the vehicles for that, the cost per inference request should be lower.
How much lower?
First principle standpoint. I mean, we're not talking a lot lower.
Like
maybe
a few percent lower?
Yeah, like maybe 5 at most.
Okay.
But we're talking
like
about
5%.
hundreds of millions of requests a day, maybe even billions.
Okay, so let's assume for a second billions of requests a day. How much can I charge for a request?
Every request is like, pennies or something. It's very little, right? Because you're
But it will decline, right? It will decline. The cost will decline over time.
Not necessarily, right? That's why ChatGPT can charge a fairly large fee for access to their LLM, right? Because it's not the request that is the expense, it's the value. The value of accessing like the most highly advanced AI is high. So, but the cost of that request is only high because the computer that runs that LLM inference is expensive. So that gets bigger and more expensive over time as the models get bigger and they get more complex.
Okay. So let's say we charge 1 penny, and we can I just want to kind of get the framework in place, and then we can discuss assumptions later.
Yes.
1 penny per inference request. And sometime in the future, we might be looking at billions of requests per day. Okay.
Yes.
So you're saying per day, this distributed inference network could be making tens of millions of revenue per
Yes.
day. Okay.
Yes.
So
If
let's give it.
Yes.
Okay, let's give it $10 million per day times 365. You're looking at billions of dollars, $3 billion of revenue. And then you said we might have a 5% margin cost advantage. So you're looking at a couple $100 million a year.
Yeah, let's put the penny request in perspective. I imagine a lot of people here use Grok. I do. And I probably do like maybe 10 or 15 Grok requests a day, but I'm paying, whatever the premium price is. It's like $16 or whatever for the premium plus access. So I'm effectively paying way more than a penny per request. Does that make sense?
Right, but you're not really representative of an average customer. And by the way, that's today. In the future, like 5-10 years from now, when we do have billions of requests a day, it's probably going to be something less than what it is today, right?
I feel differently. I've always been a leading indicator of how people are going to use tech in the future. I mean, my whole life. So my thought is that over time, the access to these, extremely intelligent AIs are going to go up because you're going to want that. You're going to want that access, and you will pay more for it. There will be more demand. The value is going to go up. Anyway, I'm happy to use a penny right now. And I think that Grok is going to be in the billions of requests per day, just like Google Maps has billions of requests. And I can talk about like over time, Tesla should have better maps, than
So let me ask you this. Billions of requests a day. When do you think Tesla's distributed inference network will get billions of requests per day? Just approximately, are we looking at maybe like a year, 2 years, 5, 10 years, 20 years kind of timeline?
No, it's probably more in terms of like when Grok turns that on. Like, let's say that Grok just flips a switch and all inference requests are sent to Tesla cars. Then we're talking about billions of requests a day. We're already
Gotcha.
talking about
So how many users does Grok have today? Do we know?
that. We don't know. I would have to
Okay.
take like a percentage of unique users for X in their interactions and then divide by, you know, or times by a low percentage of people that do premium, and
Yeah.
then divide by.
Let's assume for a second, okay, for the benefit of this analysis, because we're doing a potential TAM analysis, right? Let's assume that everyone on X will use Grok, which is a mess. Like that's a maximum assumption. It's obviously not going to be like that because people are going to be using other AI and so let's say 100 million people use 10 a day. That's 1 billion. Let's say hundreds of, so that's billions. Okay, so billions of requests per day is kind of like the max for the next 5 years, right?
Yes.
Okay. So, all right, billions per day, a penny a request, even if it's 2 penny a request, we still get to a few $100 million a year annualized profit potential.
Say that one more time. You broke up.
Billions of requests per day, a penny a request, and 5% cost advantage. We're still looking at a few $100 million annualized profit potential 5 to 10 years from today, which is immaterial to Tesla investors. You see what I mean?
Yeah, I do. Obviously, you'd have to play with some of those numbers a bit, but yeah, I see where you're going.
So let's say 1, 2. Do you see it being 10 pennies per, or is it going to be more like 1 to 2, 3 pennies?
I feel like it's probably closer to that in the short term, unless Grok gets really good really soon, because Tesla's about to solve FSD in my estimation.
Okay. Now, do you see? Let's see. Do you see the number of requests rising from 10 to 100 per day?
That I do, yeah. I don't think, and I wonder what percentage of people on this board have ever tried Grok or ChatGPT or have switched over from using Google search to just using LLMs for their requests. But I have. And so I think that's a leading indicator of that most people will.
I don't doubt, like that's not an assumption I'm challenging at all. I think everyone will start using LLMs, right? But the thing is, some will use Grok, some will use, ChatGPT, some will use Gemini, and there's going to be a bunch of others.
Yep.
So we're still, the assumptions we have, like hundreds of millions of people every day giving 10 to 20 requests a day is still very generous.
Potentially. I don't know how many unique users of X there are, but I would use that as my largest funnel. All of those people will have access to Grok, I think, eventually. And I think that they will use it. All of them will use it eventually, because it's invaluable. When you start using it, it's very hard to stop.
99.
Hey, yes, I'm back. So I just want to add more thoughts about the hardware fine and going on. I think this strategy is really, really smart. Think about when Tesla designed the next generation hardware. So for FSD, for example, that people wonder, okay, what new feature should we have? It seems that the large language model seems unnecessary or useless for FSD, but who knows? So people cannot predict where the next generation architecture will be. So even the hardware team or software team, they don't know. So they need to try, experiment, and look at the advancement of AI technology. So Then Tesla decided that, okay, we add the large language model support for the new generation hardware for the potential usage for FSD. And at the same time, if the worst case is not useful for FSD, the Tesla can use that for distributed training. Distributed inference, and for other companies like AI, and make money from them. So I just want to say it's a really smart strategy.
Sounds like you're selling the idea. Wes, I have a dumb question for you. What is how would you connect the inference computers in the cars? How do they work together?
Oh, sure. That orchestration is handled in the cloud, and it's divided up into these batches. Like, I don't know, pretend all of these requests are like chicken eggs, and you can put them into a dozen, a little bin, and then ship it off to the car. That's essentially what it's done. It ends up at the car as a batch request. So you have a set of those, and that all happens through a cloud API.
So it's still less efficient than a warehouse, right?
I'm not exactly sure what you're asking. It's more. I think it's more cost effective than sending it to a data center, because this is just idle capacity, and it's you're always going to have a set of idle capacity.
Well, there's always idle capacity at a data center too.
Not necessarily. Data centers run at peak capacity all the time, unless people are essentially sleeping. And then what they do is they ship requests from the parts of the world that aren't sleeping over to the data centers that are idle. And then they call those, spot instances, AWS does. So they always want to run their data centers at 100% max capacity, to utilize that, because everything in a data center is depreciating.
Mike Forsey. Mike Forsey. Can you guys hear Mike?
I cannot.
Okay. Mike, we can't hear you. I saw you come off mute, but we can't hear you for some reason. Yep, still can't hear you. I'm going to move you down and bring you back up. Let's see if that works. Mike, go ahead. Yeah, I still can't hear you. Not sure what's going on, so we're going to move on. Yeah, interesting topic. Thank you very much for explaining to me. And you're sending it up to the cloud and bringing it back down via Wi-Fi or 5G, and who's paying for that expense?
Yeah, wouldn't it be great if Elon also had an internet company?
Yeah, so then XAI would be paying Tesla and the owners of Teslas for to use that distributed inference compute, and then Tesla owners would pay Starlink for using the connection.
You said it. I didn't.
So who's really making money here?
The owner of the vehicle.
The owner of the vehicle.
Yep. And I think Tesla and the other parties are just going to make back their cost because that's how Elon does service. At least that's, what he said.
Now, and then let me ask you this. Do you see this driving sales for Teslas, vehicle sales for Teslas? Because I don't really see that many people buying Powerwalls to use it on a VPP.
You're closer to that than I am. The people in Austin that I've seen post about it seem like they're actually making real money. It's not nothing.
It's not nothing, but it's almost seen as like a bonus in certain areas. It doesn't appear to be widespread, and it's not driving people to buy these products just for that reason. Primarily for that, it's more of a secondary consideration.
Yeah, I mean, I hope that grows quickly because it's super cool. I would love to have the ability to participate in a VPP up here in Seattle.
Peter.
Hey Wes, so instead of running like real-time inference, right, something that you ask your Grok or phone to answer a question, but rather a scientific job, right, where maybe you're trying to run a model for a weather pattern or some other thing that doesn't require that immediate response. I think that would be a good use case for this, wouldn't it?
Oh, totally. There's tons and tons of offline inference use cases. Yep, I agree.
So another question about diminishing returns, right? So in the past, somebody came out with this great idea to put to make keyboards generate power with every keystroke, right? But when somebody calculated, how little power that actually calculates, it was just basically worthless. It would cost more to build this keyboard than it was worth, the return on the energy that you get from that. Wouldn't this kind of be the same thing essentially?
If we're talking about idle compute, inference compute that can run the latest, greatest LLMs, I would say no. I would say that is inherently valuable because we're going to max that out very quickly. And as soon as we max that out and the demand keeps going up, you can imagine that the price will be higher. Like, imagine that Microsoft runs out of inference compute for ChatGPT. Well, you're going to see the price go up very quickly.
Great. So I think the last question I have, would I be able to run like a virtual machine or a Kubernetes cluster in my Tesla then with this?
I don't think so. I don't think there's enough memory to do that. I know that they run very tiny VMs though on the vehicle, but these are not something that you could, house, like multiple VMs and have a hypervisor and, have a bunch of structure in the car because it would just run out of memory too quickly. That's my sense anyway.
Awesome. Thank you for answering my questions, Wes.
Yeah, good questions.
Peter, do you expect this to be a material business for Tesla?
I would like to see the numbers that Wes comes up with, right? Because obviously, there's a lot of variables that we're kind of assuming right now. So once we know a little bit more about those variables and we can make a back of a napkin calculation, I would like to see those numbers. It's interesting. The problem right now is that they're talking about this kind of very vaguely, right? Like there's no team working on this task and really doing anything in that direction, right? It's just sort of an idea that they throw out there. And I
Yeah,
think
exactly.
some of those variables that Wes mentioned, right? Some are very technical.
Which one?
Well, he named, a bunch of them. Like,
hold on. Let me ask you this. Yeah, we really need to be more specific in the way we talk. Like, I want to cut down on this. Like right now we have like 90% of the talk just fillers. We need to cut down on that 90%. So if I ask you, if you could time travel and literally know one variable in this analysis that we just did, back of the envelope calculation, we talked about price per inference request. We talked about potential cost benefit for Tesla. And Wes said maybe 5% because it's an inference optimized computer. Okay. And we talked about number of requests per user and number of users. Mostly going to be obviously from X. If you could know one of those variables instead of assuming, which one would you pick to know?
I would like to know, I guess, cost per one of those tokens per request, right? What is the spread between the cost of running it on our inference versus what we're charging for it? That's I think the
margin.
key. Margin.
So he
exactly.
said to that. So basically, it sounds like what's going to happen is the price per request is going to be very similar across services because it's a commodity. But the cost could be lower, according to Wes, by 5%. Cost per inference request could be lower by 5% because it's an inference optimized computer. Okay. So it sounds, I mean, I feel confident in Wes, but that's just we haven't dug into it. I mean, he requested to kind of go back and look. So I just kind of forced him to come up with a number. I mean, he said 5%. So 5% margin, cost advantage. I think one variable that's kind of, we don't really know 5, 10, 20 years down the line is how many requests per user. That one, I don't know. Like Wes said, he uses Grok 10, 15 times a day. I use all of the LLMs I kind of look at maybe a couple times a day, unless if I'm using, like I'm doing a specific task that I might ask like 10, 20. Just kind of like Wes, I guess I use it as often. And I think maybe, but the future I think is a little very uncertain on that variable. So I think I would want to know that one. Peter?
Yeah, I think the way we're thinking about those requests are like direct requests. You asking a question. I think in future, you will not be doing that. It will be different devices and applications doing a lot of these small requests for you in the background through the API, and you don't even realize that, right? And that's where the growth will be happening. And if I may channel machine for a second, it might be hyper exponential if you need a new variable. Sorry for a bad joke.
Yeah, that's exactly right. That's exactly right. That's where the potential, I think, variable we need to kind of understand a little better. Yeah. Because the math changes if we switch that, billions of requests, which is about 10 per user right now, to 100. Then all of a sudden, the potential opportunity went from a few $100 million to a few $1 billion. And if it's automated, as you're saying, then it could be even larger. It could be another order of magnitude. Wes, what do you think about all that so far?
No, it's good. It's going down the right track. I'm just trying to look up variables for cost.
Ernesto, go ahead.
Hi guys, can you hear me? Hello.
All right. Well, so which variable are you looking at, Wes?
The spot instances, those have actually gotten cheaper over time. They're now 90% less than on demand. On demand means that they're always there, always ready. You sign up with a contract, you always get access. The spot ones can be taken away at any second. So that's why they're so cheap, because it's just idle resources. So I'm trying to figure out what the cost of those are, and how many LLM requests they can handle a second. That's what I'm looking for, and I'm having trouble finding that data.
Well, take your time. No rush. Dina?
Hey, Yaman, my audio was in and out. I might have missed something. My question is for Wes and also you. Speaking of requests, based on an assumption that what percentage accuracy are we talking about? In a recent interview about 2 months ago, Elon was specifically talking about Grok and how inaccurate it was because it was fed information mostly from mainstream media, and he would have to literally obviously invest time, and I don't know how much it would cost to basically retrain it. So when you guys are talking about request, two questions: is that based on assuming that it has like a 99.9% accuracy rate, and multiple requests, say the same question, the same topic, is that treated as multiple requests? Because those seem to be initially things to assume before talking about profitability and all that stuff. Your thoughts?
Yeah,
Yeah,
we're doing it. We're just brainstorming right now. I mean, obviously, all of these LLMs are going to get more and more accurate over time.
Yeah, it's a good question. Let me chip in real quick. So that on the training side, that's one thing. And when you ask it for an output, that's the inference, when you actually prompt it and ask it a question. That accuracy will depend on how well it's trained. So we just assume that training is going to get better over time. On the inference side, you would expect that when you ask it, it tells you the right thing, so you don't have to ask it to check itself. So every request would hopefully yield you the right answer, and maybe 1 out of 100 you might have to re-ask.
Wes, what do you think about this request from AI for Everman to a truck?
Sorry, where is this? Is this on YouTube Live or
Yeah,
something?
I pinned this up.
Oh, sorry, it's at the top. Let me read it.
And on YouTube, it's on your screens.
Okay, so I think they're doing both. I think they're hopefully reading, even though there's a few patents around that, but I'm sure they're able to work around those, as well as creating heat maps of where these signs are, and also using road data to understand if that sign makes sense for that road segment. So I would assume they're using all of that to determine what is the right speed for the road. And not to mention that the Google Maps API that I think they might be using, the traffic API, actually will give you real world speeds. So it will send you that information in the API. And I think Tesla is using that in conjunction with, traffic density, real-time traffic density, to determine what speeds to drive.
So you're saying Tesla will not drop using the map data. They'll continue to use map data, and his frustration will continue.
No, I think this is going to get way, way better very quickly because of the example that I talked about earlier, where something failed, a maneuver failed almost all the time, and then the very next day it passed every time. The same thing will happen for mile per hour signs.
Got it. All right.
Say, I found a little bit of data that I'd like to share. So a spot instance with what I think is about a similar size to the Trip Hardware 3 chip is 2 L4 GPUs running Llama 2 7 billion token model, can process around 1,200 inference requests a second. So that's kind of my starting point. Now I have to figure out how much that costs. But anyway, that's kind of the beginning.
Got it. Thank you. Yeah, I mean, this is definitely a thread-worthy topic. You know, but like just kind of as a rule of thumb, it sounds like potentially billions of dollars of annual profit 5 to 10 years down the line kind of opportunity.
Yeah, it's not nothing. And I would think that they would potentially utilize this. I could see the Grok engineers are architecting this and writing the code, and I could see a few engineers doing code review on the Tesla side. So I don't think this takes away from Tesla development. I could see the Grok engineers doing this because it's going to save them a ton of money.
Okay. Steven?
Hey, thank you. Just a quick hardware-related question. Since
Okay,
originally,
so I want you to go back down and try again. And what you're going to try again is you're going to skip the hi, thank you, and you're going to skip a quick question. Just start with the question. Okay, so I'm going to move you down, request to speak if you want to ask your question again. We'll try again. Wes, there's another question in the replies that says, how much power in kilowatts does inference compute take? Like how much inference power is required on AWS data centers?
It depends on the chip and the instance. And we talk about, thousands of requests per second per watt. So that's kind of the rate, for efficiency. Gotcha. So like as I can talk to the TPU chips because that was my thing. So we went, like we generally increase 20 to 30, as much as 50%, thousands of requests per second per watt in every generation of TPUs. And that's just for inference. That's not for training. So if that gives you an idea. And then to put it more precisely for hardware 3, I believe Trip is 100 watts and it's able to process 37 frames of stitched video from all 8 cameras per second. So I would have to equate that to LLMs, which I'm still in process of doing because I've never done the calculation for LLM cost.
Gotcha.
Per batch
Yeah.
request.
Gotcha. Okay, Dallas Tesla.
If they begin using the onboard computers for, I know they mentioned like widespread compute on vehicles that customers own, do you think it's fair that the customers should be, or the vehicle owners should be compensated since we own the hardware?
Yeah, that's the idea. That's the idea. Just like Powerwall owners get a credit to your monthly payments or energy bills, the Tesla owners would get some sort of credit in this hypothetical example, hypothetical future. I'm just trying to kind of understand the magnitude of the credit right now. Like really, the litmus test is, will people buy a Tesla for this additional benefit? That's really the litmus test. Would people buy a Tesla with an inference computer in it for this additional benefit? Steven.
so where's the power going to come from since already the vehicles are struggling to get the range that they're being advertised as? Once you start using these as,
Great question. All right, great.
Grok instances.
Wonderful job. Where is the power going to come from, Wes? We're already struggling to get the range. What do you think?
Yeah, this is only occurring, just so everybody knows, when the vehicle is idle and parked. And for instance, Sentry mode is already running inference. That's how it monitors the surroundings of the vehicle. So it's already running inference on constant video feed to make sure
Perfect. And when it's not plugged in, it's draining the battery. So running inference, if the car is not plugged in, would drain the battery, right? Similarly.
Yeah, just like Sentry Mode does. Same thing.
Yeah,
so just
exactly.
assume it'll be the same drain as Sentry Mode. Just
Perfect.
as a rough estimation.
Dallas Tesla.
Is there a way to limit that to, like, does the vehicle know when it's plugged in, and could they only shovel this out to the cars when they're plugged into the wall being charged?
Yeah, totally.
Yeah,
so
of course.
assume that this would only run when your vehicle isn't running Sentry Mode and is parked, and you could say like only do it when it's plugged in. So you probably have that, that toggle.
Perfect. Gianni.
Hey guys, I like this discussion because we're thinking about Tesla ecosystem, how it helps
Question.
customers, how it helps.
What's
Tesla.
your question? Did you have a question?
Question is 10 year. Yeah, I have a question.
Well, we're gonna try again. So go back down, and then request to speak again, and abide by the rules, just like Steven did. And when Steven revised his method, it was so much more efficient. And if everyone can do this, we're going to become 10x more efficient. It's going to be great. It's taking a while to get there, but we'll get there. Gianni.
How does Starlink integrate with Tesla in the next 5 to 10 years to benefit Tesla and customers in the ecosystem? Any speculations? Question mark.
Wes.
Yeah, let me utilize my imagination. So a given Starlink terminal can be plugged in to your vehicle via, on Cybertruck, it can just be plugged into the, outlet in the back. And then that terminal can run on some amount of watts and connect to the internet. And now you have a connection to the internet with your vehicle. And then you can drive that vehicle anywhere, and Starlink will remain connected always, as long as you have a view of the sky. So imagine that, imagine that your vehicle didn't need Wi-Fi and didn't need cellular to connect to the internet all the time. And some amount of watts is used, some amount of energy is used to power that Starlink terminal. And that's my imagination running wild.
Can you take it a step further? Something that is just outlandish and that we wouldn't suspect, kind of the way we would not have suspected the prospect of AutoBidder 10 years ago when contemplating energy, that there'd be a software component and a profit stream from that.
Well, just let your imagination run wild with, I don't know if you're familiar with Starlink and the different terminals, the different dishes, the flat white things that have come out over the years and how they're changing. And if one were to be very interested in this, one could look up the amount of watts that those things use in every new generation. And one could maybe come to the conclusion that amount of watts might be dropping over time. And the dishes are getting smaller, and they're getting way more efficient in general of accessing data. If one was interested in looking up that data.
Steven.
For a vehicle using FSD versus a vehicle not using FSD, do you know the difference in power consumption, Wes, sir?
Yeah, no need to say, sir. I appreciate it though. It's kind of funny. I'm old. Yeah, it's 100 watts. The FSD computer is 100 watts. So to fire that bad boy up, you would consume 100 watts, which is, not nothing at full bore, and then the chip itself, I think the chip itself is like, I want to say 14 watts each, for a total of 28, but then the whole board is also consuming power overall. And then there's other supplemental things that have to be supported. So I think it's roughly like 100-watt drain, which is not nothing, but it's still very small, all things considered. In other words, like you could run that thing for 10 hours and it's a kilowatt of power, which costs 8 cents for me in Seattle.
Thank you.
Can you imagine if like every single person had a question in this room and everyone took 10 seconds to ask their question? 10 words or fewer, 10 seconds, and no filler words. So that would be 300 times 10 seconds divided by 60 seconds per minute. We'd be done in an hour, under an hour. 300 questions under an hour. Ivan.
Yeah, my name is Ivan. My question is to Wes. What is limiting Microsoft or Sony to implement this in inference computing on their devices, basically the gaming consoles?
Great question.
Yeah, great question. I used to work in Xbox, so these computers, the consoles, these are not always on, and their chips are custom GPUs. Like they're very, very custom. So they do not have anything, any way, shape, or form, the ability to run CUDA on top of them. Not to mention that they're not NVIDIA chips. They're custom silicon from AMD. And so the Xbox One used to be a custom Jaguar core, and I believe the PlayStation 5 is still a custom Jaguar core. And these were developed during the time, literally during the time of the first neural nets like ImageNet were developed. So they do not have that stack on top of them. And just so everybody's clear, CUDA is the library set that allows GPUs to kind of run inference along with other things, but CUDA is kind of the big thing. So they just don't have that possibility. So the ability to use that for inference, I think, is very, very low probability.
Ivan, does that answer your question?
Yeah, it's very clear because I saw some post in Twitter saying that Microsoft can launch the same thing to their devices as well. Yeah, that is why I asked this question. Yeah.
Yeah.
How much more capable are the hardware 4 cars, if any, versus the hardware 3 for fleet-wide inference?
Yeah, we don't know the compute specifications for hardware 4. I'd love to know it, but that detail is not available. I'm just kind of make the assumption that they've increased all areas of the board, 30 to 50%, maybe more. But I think that's probably conservative. I think that's, safe. So
Perfect.
I would expect somewhere in the region of like 900 tops, trillions of operations per second, something along the lines. But that, again, that might not even tell me like how efficient it is. There's other specs that you would need to know.
Okay, we have Jordan on the board. In a minute or two, we're going to switch and ask Jordan about the CATL's new battery after we go through a couple more questions on Tesla's distributed inference compute potential. Okay, Steven.
Does Tesla have the ability to increase the output of their in-house chips if they do, in fact, get a contract with a major OEM who adopts their FSD software, who would also need their in-house chips in order to make it all work? Would they be able to meet that output? Thank you.
Yeah, totally. I think that they have enough fabs making these chips and would have enough insight into the run rate needed to fulfill the supply chain demand requirements, because that would not be the bottleneck to implementation in their vehicles. The bottleneck, and I think I said this in a tweet, the bottleneck is packaging of the B-pillar camera in the chassis of these vehicles, because that's crash safety part of the chassis. So they have to redesign that, and then they have to get it crash tested. So that's the bottleneck. Good question.
Thank you, Ravi. Ravi.
The inference computer hardware 3, hardware 4, I remember Omar posted that it is 400 tops, but I could not find the specs anything online. A question for Wes is like, do you have a prediction for the performance of the hardware 5 in terms of tops? Do you think it will be close to a petaflop?
They just asked that question. Gianni.
Wes, is that B-pillar camera outsourced or is that in-house Tesla?
With hardware 4, I'm not sure. With hardware 3, it was definitely a Sony sensor, and then a custom developed interface board between the sensor and the data stream.
Is it practical?
The actual image processing off the raw data was at least we turned that off for hardware 2. I don't know what they did for hardware 3, but we turned it off and we did all of that processing locally.
Would you predict Tesla with their vertical integration inevitably brings that camera in-house and then
It's
sells
immaterial.
these components?
Immaterial.
Probably not.
A12,
The sensor.
A12X. A12X. Gideon.
Yeah, will Optimus be able to do inference in the future?
Yeah, it's the same board as the vehicle.
Okay. Dan.
Wes, could the electronics from Dishy McFlatface be integrated into the glass roof of a car?
Rest.
Sorry, I need a minute. My bad.
Okay, that's okay. Hi, Jordan. How are you?
Not bad. Can you hear me?
Yes, we can hear you. We
Hey,
are skipping those questions, but the question, yeah.
Is this camera button new? I've never seen that there before.
Yeah, I think it's new. I saw that today too. Are you on your desktop?
Yes, I am.
Yeah, and there's the mute button and everything too. I mean the microphone buttons. Yeah, it looks like they changed the desktop version of it. But
cool.
The question for you that we have is the CATL battery. So I'm going to pin at the top. CATL just announced a new LFP battery that is supposed to be, let's see, introducing Shangxing Plus, the world's first LFP battery to offer a super long 1,000 kilometer range. So you're looking at, what is that, 600 miles with 4C super fast charging. What do you think about this?
Well, when I look at the slides, it says 1,000 kilometers of range, which, that's that sounds pretty good. That I think if you factor in EPA test cycle, I think that would probably be like 500 miles of range. But that's still really excellent. 4C fast charging, I don't know whether they're talking 0 to 80% or 0 to 100%. So when I look at the slides, it just leaves me with a lot of questions. But CATL does great work, and when I see something like this, I just think, okay, they're increasing the energy density. They're increasing the fast charging speed. As far as the specs goes, I don't know. We'll actually have to wait till it gets into a vehicle until we know what it's actually doing. But I do have some ideas on how they were able to do this. It may increase the cost. However, unlike a year or 2 or 3 years ago, the price of battery cells are getting so cheap now that it may not be the first priority for a manufacturer. Do you get like a regular LFP battery cell for $55 per kilowatt hour, or do you get something like this with a few more bells and whistles for like $65 a kilowatt hour? In both cases, you should still be able to make a profit on the EV. Whereas like a year ago, LFP cells were like $90, $100 per kilowatt hour. And at those prices, it becomes difficult to make a profit.
When would you expect this battery to be in vehicles?
Well, I thought I saw something that they've already put some of these Shunxing batteries into some other vehicles, but I didn't look deeper into that. So who knows? Quite often we see with CATL they're announced something, and we never see it at scale in vehicles for at least a couple of years. I mean, they announced M3P 2 years ago now, and we've been hearing rumors every 6 months that they're going to go into vehicles imminently. And there's been a few other chemistries that they've done that we really haven't seen rolled out in mass production. So most manufacturers have just stuck with their regular LFP battery cells.
Dan?
Yeah, the 4C charging rate is very impressive. If, of course, they aren't degrading cycle life. That'll be the interesting thing, because that's like 16x, 32x normal charging speed ratings, because normally they're at a 0.2 kind of a charge.
Yeah, well, it really depends on if they're talking about 0 to 100%, because you can. There was an interview a few weeks ago with one of the Tesla employees about, how can we increase the fast charge rate? And Tesla said, yeah, we can massively increase the charge rate of our batteries as well, but it would require adding a specific type of electrolyte that reduces ionic conductivity, but that electrolyte is more expensive. So we've decided, made a decision to go with cheaper battery cells rather than battery cells that charge faster. So everything that I'm seeing in this slide, it's like, yes, all the technology is definitely on the market to do that. It's just, what sort of trade-off decisions do they have to make there? If they're able to produce these batteries at the same price as a regular LFP battery cell without extra degradation, then I would be super impressed. But I have a feeling there's going to be some trade-off decisions.
Yeah, that'd be really nice in something like a semi. A car would be a waste because the battery's going to be so small anyway. To be able to charge it that fast, is, I don't know that the benefit is there, but something big like a semi, that would certainly be beneficial.
Oh yeah, something like this for a semi. You're getting to the point where you might be able. Well, I don't know. I think semis would still use high nickel battery packs for the long range, but something like this for like a short range semi, they could do regular LFP, but with the extra energy density and extra charge performance they're getting out of something like this, it might be worth the extra few bucks for those capabilities. And I think it's worth pointing out that I don't think they've done this with just one technology. I think they made a slight tweak to both the anode and the cathode, a slight tweak to the electrolyte, and it's kind of a combination of technologies that allows them to um, hit this improved performance. So, a manufacturer like Tesla could say, hey, we don't need all that performance, but could you give us something that's, roughly the same price as we currently have, but could you give us just a little bit extra fast charging speed? So I think it's a good technology platform to showcase what's possible at the very least.
Thank you, Jordan. Dina?
Wes, could you go over any specific downsides of this battery? The pros, we know, it's more cost effective. Charging may be more effective, but as far as suspension and acceleration, would that be noticeable changes?
I think she
That's
meant Jordan.
Yep.
For this battery, it says they're getting 205 watt hours per kilogram. I think that's what it said. If that's the case, you could either get longer range with the same weight and the same performance, or you could shrink up the battery pack a little bit in terms of weight and get better performance. So it looks like all around on each point of the spider chart, it looks like they made performance all the way around.
Any questions for Jordan on CATL's new battery announcement? Please request to speak. Jordan, what do you think of Tesla's 4680 comments on the call?
I actually just finished my script on that. It was the way I'm framing it for my video is that there's a whole bunch of rumors before the earnings call that they're like going to shut down the 4680 ramp or something like that. I was like, okay, whatever. It just sounds like scuttlebutt and BS from clickbait articles, and that's pretty much what was confirmed in the earnings call. They're making slow but steady progress, not as quick as we'd like, but things seem to be going well. My main concern is they keep ahead of the Cybertruck ramp, and they are. And there's ways for them to continue. There is a pathway there for them to continue increasing their production. But I do think, even though it's good enough for the Cybertruck ramp, I do think they've missed some opportunities to, because the ramp is going slower. I would like to see the 4680 battery cell in the Model 3 so they can reduce so they can get the $7,500 tax credit. And if they would have ramped the 4680 faster, then they could do that. But they'll eventually get there. But it's they're not shutting down the 4680 ramp as some outlets were saying.
So would you need like higher wattage superchargers and able to get that increased charging speed, or which is the current limiter right now?
So with
Depends on the
Tesla's
battery size.
Yeah, with their current chargers, you'd be able to get a much faster charge rate out of this battery cell.
Exactly. I mean, if you have a 50 kilowatt hour battery and you have 250 kilowatts chargers, right, Jordan?
Yeah,
then you can go up to 4 for sure.
Yeah, so I imagine this would have a higher peak charging rate, so it could accept like a 350 kilowatt charger or something like that. But where it would really where you'd really see as an improvement is it would probably accept that higher charge rate for longer. But this is one of those things where you also have to look at how big the battery pack is. So if you take a standard LFP battery pack, something like, I don't know, 60 to 70 kilowatt hours, the battery pack is very much usually the limiting factor for how fast it can charge. So to be able to accept a higher charge rate, it would be able to take more of the existing supercharger power. So
Do you think this would be a good battery for robotaxi?
if they're focused on cost and this battery costs more, I think they just use a typical LFP battery cell. And it also comes down to they're going to have to outfit factories in order to produce this battery. Whereas if they're ramping this next gen vehicle next year, they'd probably want batteries that are well established that they can just pretty much buy off the shelf. They don't want to have to worry about building scale and infrastructure around that. So, maybe in a few years they could use it, but I'd say most likely they're just going to use a standard LFP battery cell because it's cheaper and the scale's there.
Okay, great. Thank you. Any other questions for Jordan? Please request to speak. So Jordan, based on the comments from the call, you're not changing your forecast of 4680 production ramp, right?
Well, there was kind of this requires a bit of history. So late last year, the indications were that the ramp was going to continue, and but then we found out after the last quarterly earnings call that they actually had to shut down the lines and retool to switch to the Generation 2 cell. And at that point, it's like, okay, it's all bets are off. I'm going to, scrap the forecast, etc. So we've gotten one new data point with this 4680 ramp. We probably need one more in order to actually get an idea of where it's going. That's a good question. I'll have to think about that for my video.
Great. Perfect. Thank you very much. Wes, did you have a question for Jordan?
Yes. Can you hear me? Hey, Jordan. Two kind of similar questions, I think. And Yaman already did part of this, but when do you think, or what do you think is the probability of seeing this in a car before the end of the year? And do you think the form factor is going to be compliant with Tesla vehicles?
You can make any form factor work for any vehicle, really. The odds are really high odds. And actually, I think I saw on one of the slides that they're using a prismatic form factor. I don't think this is going to be used in a Tesla vehicle anytime soon, but I imagine that they're, like they did with the first generation of Shunxing, I think they're probably going to put this in some sort of low volume vehicle in the near future just to show it off. But as I said earlier, quite often, CATL will announce something like this, and it can take up to a couple of years to get it into a vehicle. But I imagine something that's, this isn't super cutting edge. Everything that's required to make a battery like this, they can probably get off the shelf. So yeah, I don't see any reason why they couldn't put it in a vehicle by the end of the year, so we can get a good glimpse of what it can actually do.
Gotcha. So this isn't like imminent mass production.
I didn't see any scaling figures with it, but it's I imagine that they would build a new factory for this rather than cut over existing LFP lines for it. So yeah, it's a black box from that perspective. I don't know if they've shared that information. What I'm saying
Thank
is they could do this immediately if they wanted to. Will they? I don't know.
Got it. Two questions for you, Jordan. One, will power share come to all Tesla vehicles at some point from 2018 to present?
I don't know. That's I haven't really focused on power share. I know there's a small group of people that are very passionate about it, But looking at the current costs that I've been seeing online today, I don't know if that's something you'd want to put into like a robotaxi.
Yeah, and it also sounds like there's a lot of bottlenecks to get it implemented, like on a per user basis. Like, it just has to come out and do some work, and permits have to be pulled. It sounds like a nightmare.
Yeah, right now it seems more of a luxury feature that a small number of people could utilize. Something like, for instance, truck owners or people living way out in the country might appreciate. But I think for a robotaxi, there's better ways to utilize the capital in that vehicle. For instance, as Tesla said, doing distributed compute.
Got it. Thank you. And we've been talking about that for the first hour. If you all want to listen to our discussion on distributed inference compute potential for Tesla, you can rewind on YouTube or go back to that section after this space ends on it. Jordan, another question for you is, will sodium-ion batteries become the dominant battery for vehicles, if ever?
In the longer term, there's a potential for that. But what we see is lithium-ion batteries just keep getting cheaper. So it's making it much harder for sodium-ion batteries to compete. There was a lot of talk about sodium-ion batteries a year ago or 2 years ago because lithium-ion batteries were so expensive, and that was driving a lot of people to look into them. But now that lithium-ion batteries are getting cheaper again, it's just not. We might see a slowdown in the investment of sodium-ion batteries. And this is something that Shirley Mung mentioned to me a couple weeks ago when I interviewed her. She's like, a lot of these cost modeling that they did for these sodium-ion batteries, in order to get them off the ground and do the initial investment, they were dependent on high lithium-ion battery prices. But since they've dropped, there's, the investment might not be there. It just might not be worthwhile. But, in the very long term, sodium-ion batteries, at the very least, will slowly build scale, and the first principles benefits of using cheaper materials will eventually come to dominate. So Best case scenario, in the next 3 to 4 years, we might see sodium ion batteries widespread in vehicles, but I think it's more likely that it would be like early to mid 2030s for vehicles. Grid storage, different story. I think they're already using sodium ion batteries increasingly for grid storage.
Are you happy with how Tesla Energy is progressing, Jordan, or is it progressing slower than you expected?
Slower than I expected. I'm glad they covered it on the earnings call, but it's like this manufacturing line, on paper, it seems like it should be easier to ramp than a vehicle line. So, what's the holdup? And are we just assuming that it's easier than it is, or am I assuming that it's easier than it is?
I
Because
think it might be. I think the bottleneck is somewhere else because I agree with you. We talked for years in here that it should be easier to ramp megapack production lines than a vehicle production line. But I think if the bottleneck is somewhere else, like say the interconnect backlog, then why ramp it, right?
yes, and I think they hinted to something to that effect on the earnings call. I think they said some external factor, but yeah, the interconnect queue is it's long right now.
How long is it?
Oh, I have that information somewhere, but it's yeah, I would have to search for the slide. I don't have it right off the top of my head, but it's
Yeah,
months, and it's like 80% of
I
them
thought
are in the interconnect queue.
it was more like years, like several years.
Yeah, it's at the very least months, but I think you are right that well, I think there was like, for instance, for transformers, just for those, I think there's like a 2-year wait for them, and that was a year ago, and it's probably a longer backlog now.
Yeah, Chris, you have to unmute yourself for us to hear you.
Hi, Jordan, this is Chris. I just wanted to see if you could elaborate a little bit on Musk's seeming ambivalence on the call about more domestic battery construction around the IRA, and his comments about the 4680 lent themselves to this kind of takeaway, and how much either stationary or future production auto is going to come through the Mexican backdoor, or how much. And it's a tough geopolitical question, but I think you're as good as anybody to maybe give us some color on getting these cheaper LFP batteries and cheap lithium in through the Chinese route rather than domestic.
I'm not sure I followed. It sounds like there's a few questions in there. Could you?
Yeah, so I actually it's very. I want to emphasize again, and I'm going to emphasize this very often going forward. Questions must be 10 words or fewer, and the reason for this is because eventually we want to get to a point where we're answering hundreds of questions in an extremely efficient manner, and I think this is going to be very important over the next 10 years.
Okay,
so we really have to get there. We really need to get there.
Simple. Can you contrast domestic battery production versus Chinese in Tesla's stationary and mobile future right now?
Oh boy, short question, huge topic. Because there's the time aspect, it's going to change over time. There's what it is currently, and then you have two different supply chains, or multiple different supply chains for different products. Where do I even start there? Okay, so currently there's a glut of battery cells, and that comes from both mostly China, but it sounds like it's also building in the U.S. as well, thanks to all these plants that were ordered up by GM and other companies to meet their U.S. demand. So in terms of Tesla's growth, the 4680 program, as they said, has become less important. In the very long term, the 4680, I think, will become more important, but it's not important now because of that glut. I'm trying to think where else I could go with that. Yeah, go ahead. I'm trying to think where else I could go with that. Yeah, go ahead.
Yeah, he seemed as though the IRA came up on the call a little bit, and it almost seemed as though that was part of the tell of the call, was that it seemed like it might be leaning more international rather than domestic, but it comes against the cost, which you know best.
They're going to keep focusing on first principles improvements to the 4680 cell and to their supply chain, because they don't want to be overly dependent on any outside source. So at the time being, they're going to take advantage of these cheap cells, but in the background, they're going to keep working on, as they said, they're hedging their bets with the 4680 ramp. And they don't want to be overly dependent on China in the long term in terms of their supply chain. So they're going to keep building this U.S. supply chain in the background and continue working on the 4680 technology. I don't know if that helps or answers your question, but.
Good, thank you. Mike.
Hey, this is Mike. I was just commenting that the interconnection queue usually varies per ISO and per utility. But they are very long, and that is mostly due to utilities are very slow to move and a very manual process on managing this stuff coming in, renewables, batteries, solar, and all the rest.
Can you give us a range of the backlog?
Mostly familiar with the New York area, but things seem to be taking between 6 and 18 months.
Oh, and one thing worth noting on the IRA point is I think Tesla is trying to avoid letting the IRA influence their decisions, because as they indicated in the earnings call, the IRA is creating market distortions, read market inefficiencies in the supply chains, and it could be yanked away at any moment. So there's no point in really structuring their supply chain around those IRA tax credits. Not that there's no point, but it may not be worth their time if they could just be taken away at some point after they did the hard work of restructuring their supply chain to qualify for them.
Yeah, makes sense. Mike, interesting. So 6 to 18 months, you said, in the New York area. I've heard as high as like 7 to 8 years. Did it improve recently?
I don't know. I just read an article today about a 42 or so megawatt project going in New York City, and it looked like it had a 2025 timeframe. I was assuming that it maybe just was estimated to be in the queue last year, so that would make that maybe a 24 month.
Yeah.
Yeah.
So, do you see that backlog shrinking? Like, do you see that wait time shrinking going forward, or are they getting longer?
Hard to say. I'm not that super close to it. I'm more close to the cost side of valuing energy and such. But yeah, there's a lot of negotiation going around right now in the New York ISO about capacity accreditation, which says that how should we value capacity for a natural gas turbine, a solar farm, a battery plus solar, and all those kind of discussions. But New York is very open to these renewable assets needed.
Okay, got it.
Yeah.
Thank you. You have something in the background. Some kind of like thumping noise. Dan Caro. But thank you, Michael, for your expertise.
Yeah, I was just going to comment on the 5 to 7 years. That might be for the entire project, because like most of these utilities would only have a 5-year budget, especially a capital budget, because governments won't typically let you go much further out than that. So 5 to 7 might be like from the time they say, hey, let's do this until it's done. But the actual interconnect is probably a lot shorter. Well, would have to be a lot shorter than that. That might be where the confusion with the numbers are.
Okay. Thank you. Any other questions, comments? Please request to speak. If you have expertise in Tesla Energy, Megapacks, stationary storage, installation of these projects, please request to speak. Dan, I think you have a coffee bet with Wes, right? On total gigawatt hour annualized production by the end of 2024. I think you said something like 60.
Yeah, I owe him a coffee.
Yeah, yeah,
That is
they're just starting. Yeah, they're just starting. See, Wes, we're looking out for you.
No, I appreciate that. I'd honestly put that one in the back of my head.
Yeah.
Hey, can we loop back to that idea of putting the electronics from Dishy McFlatface into the glass of a car on the roof? Is that possible?
Wes.
Let's do a quick mental thought process. If you were to take a current dish and mount it with suction cups on the inside of the glass of a Model Y, do you think it would work?
I've heard of people doing that, and it does. I don't know if it has the full strength or not.
It does.
Yeah.
So I will let you run with that mental image.
Thanks. I realize where you work, and you can't give full answers.
All right, great. Great. Any other questions for Wes or Jordan? Please request to speak. Checking the messages. Let's see if there's anything here. Wes, did you place the order for the Model 3 Performance?
You know, I did. However, something just happened in Washington State that Matthew Donegan Ryan posted. Apparently $9,000 off a lease. And so now I'm thinking I might change my tune. I'm not sure I qualify, though. I still have to look into these details. Anyway, if you live in Washington State, just got amazing.
I pinned at the top of our screens what Matthew Donegan Ryan posted. Breaking: Washington State launches new EV incentive of $9,000 per vehicle. 3-year new EV leases receive a point of sale $9,000 rebate. This makes 0 down leases of $127 per month for the Model 3, $207 per month for the Model Y. Eligibility: new EVs purchase or 2-year lease, $5,000. More than 3+ year lease, $9,000. Used EVs, interesting. So there's a rebate for used $2,500 purchase or lease. Eligibility: customer eligibility. Washington residents making 300% or below of the federal poverty level in the household income equivalent to $93,600 a year for a family of 4. Vehicle eligibility: full battery electric vehicles with manufacturer supply retail price of $90,000 or less. Automakers that sell eligible vehicles, etc. First low cost EV lease program in the US. Great. Great. Dallas.
Hey, Wes, does the Tesla AI team decide who to pull driving data from based on like driving skill or like how you drive? Because I've noticed since I've had the trial and I'm now subscribed that the first week my home network was pulling like 40 gigs a night or uploading 40 gigs a night. And then, I'm not the world's best or safest driver. And I've noticed that's tapered off a lot since then. So just curious your thoughts on that.
They talked about it. Good question. They talked about it on the call, and they pull disengagement data And it sounds like they're doing some evaluation locally, but then doing more like intricate evaluation aggregate in the aggregate after it goes up. So it sounds like they are sending a lot of clips up and then sorting and filtering them out. And that all sounds like it's happening with humans out of the loop. That's what Ashok described, that it was automated.
Do you think that would use like a safety score protocol? Because I'm just
No.
curious how they're coming up. No.
Nope, completely not, because they don't care what kind of a driver you are. They just care about these clips. If they can get a good clip from you and you're not the best driver, it doesn't matter. They're just looking for good clips. They don't care where it comes from.
Gotcha.
All right, this space has been going on for more than 2.5 hours. If you'd like to support the space, the link to Patreon is at the top of our screens. Without patrons, this space would not exist.
And
Wow,
I'll probably
ahead.
head off in a few minutes. So if you have any questions, let me know. Otherwise, I'll head off.
Jordan, it's always good to have you here. I mean, it's just invaluable information that no one here has. You're the only person who has this information. So
I'm glad it's useful.
Lincoln.
Yeah, what makes a clip useful? You say useful clips. What makes it useful? What are they looking for?
Yeah, gotcha. So anything that is unique that they don't have already. So for instance, what makes a clip useful in practicality or in practice would be a turn that, let's say, 100 Teslas make, no problem. And then the 101st Tesla drives through and has a disengagement. They would flag that. They'd be like, wait a minute, like this is a rock solid turn, like what's the difference? And then the algorithm goes in and looks at the clip and tries to pull like interesting features out of it. And then also looks at the other 100 clips that they have of that turn that works. And maybe, you know, the other like 10,000 clips that they have of a similar turn that also work fine. And they go, what is different about this turn? And they look and they keep looking and the algorithm keeps digging to find unique features that make that more difficult for the AI to complete successfully. And then if they determine that that is a more important clip to include in the next round of training, they'll switch out. You know, it's kind of like they prioritize these clips, I would assume, in some way, form, or fashion. So they would use that clip instead and just replace it. Another clip would fall out. And they would expect reliability to go up based on that. I hope that helps.
Okay, Max.
Yeah, just a quick question since we're on the topic of batteries and IRA stuff. And since we have the limit in here, is there any chance in the foreseeable future that, say, more Tesla vehicles will qualify again? For example, like, you know, the long range Model 3 will qualify for the EV tax credit at some point, or is Tesla not really interested in restructuring to an extensive level right now? What is your guys' opinion on that?
Yeah, Jordan already answered this earlier, and he said Tesla is not making major changes to fit into IRA mold because these things are changing constantly, and it may not be here after the election. Jordan, is that a good summary?
I think that's with regards to the 4680. I think that is the case. I think that overall that they will be gradually moving towards trying to localize the supply chain here just as much, and that would be regardless of whether they'd be pursuing those IRA tax credits or not. So now my view is that I'm hoping what they do is they either increase the production of the 4680 and allow for those tax credits with their in-house production, or the 4680 cells that are coming online from LG Chem and other manufacturers. Hopefully those will start hitting the US market from their US produced factories, and then they can take advantage of some of those. So I'm hoping that even though I don't think they're building their strategy around it, I do think they're pushing in that direction, and hopefully it does result in some additional credits for the Model 3 to get more of those pumping. And maybe they're even mentioned something like that. I doubt they will, but it would be good if they mentioned that in August. Say, all right, here is our roadmap for reducing the cost of these vehicles. One way to do that would be to use more U.S. sourced battery cells, and that would be regardless of the Inflation Reduction Tax credits or not. You save shipping, etc.
Thank you.
Dallas.
I've got a question for the limit while we've still got him. Similar to what we saw with this new version 12 UI update, how the people with Intel Atom chips are being kind of limited out of this future update, allegedly. Do you see any issues for vehicles like most of us have right now who don't have 4680 cells with future supercharging or, speed updates coming down the road for charging as a whole? Do you see that as in the next 5 to 7 years as an issue for the vehicles we have now that don't have 4680 cells?
That's a good question. I think they're going to try to keep the performance of their 4680 cells. Well, not that I think they're going to try to keep the performance the same as 2170 cells purchased from other manufacturers. But the thing is, every major manufacturer is pursuing the same or most of the same strategies in order to increase the energy density and increasing the charge speed. So as long as they're each kind of keeping pace with each other, I don't see a lot of divergence with the 4680s, at least in the near term. Now, deeper into the future, I think the 4680 does have some fundamental first principles advantages that may allow them to increase the energy density and charge rate faster than other manufacturers, but I don't see them implementing those technologies until deeper into the future. So I think currently the 4680 is roughly on par with all the other battery cells on the market. The first generation of the cell that was in the Model Y last year, that one had lower performance in terms of energy density and charge speed, but this one is pretty good. It's kind of middle of the pack.
Maydad Avioni. Maydad Avioni. Please unmute yourself. And
Hi. Can you hear me?
Yep.
Yeah, if you ask, sorry guys, but the rule is if you ask, can you hear me? You get moved down automatically. Dan?
Yeah, just on that previous question, just to clarify, it's really up to the BMS, not the battery, how fast it'll charge. So if Tesla wanted to speed up the current charge rate of your current battery, they could do that over an over-the-air update just by updating the BMS. So if they find efficiencies that doesn't degrade the battery too badly or different, charging faster in different parts of the curve, they could do that at any point in the future.
That's correct. It's complex. There's the fundamental. Oh, I don't know if I want to get into this now. I'm going to be releasing a video that explains all this here in about 2 to 3 weeks with a guy from the University of Oxford who specializes in these charging curves. Basically, what they do is there's some fundamental limits to the battery cell. They test thousands of these battery cells in a variety of conditions to understand exactly where and when lithium plates. And then they build the charge curve around, all right, this is a good balance between degradation and charge speed. Now, you can accelerate the charge speed, but then you're going to create some potential degradation. So it's a little bit of both. It's a hardware and software thing, kind of marriage in order to select that charge rate. But it is correct that you can update that at any time just by changing the lookup tables in the BMS.
All right, great, Jordan. Thank you very much. Appreciate your contribution to this space and you answered dozens of questions today. And, on behalf of our audience, I thank you.
You're most welcome. And these spaces, you're doing a really good job of running these. I've noticed a significant improvement from the past spaces I was in. And it's good to know in the future, I won't ask if everybody can hear me. I didn't realize that was a rule.
Yeah, I'm trying to make it very efficient. Kind of get into these zones when we have someone like you and others that come into the space. I want to get as many questions answered as possible. And I think there's a huge amount of fluff in the question format. Literally start with the 5 Ws or 1H, what, when, why, who, and where, and how. If
Well,
you start with those keep it to 10 words, we can run through hundreds of questions in 1 hour. Then we don't have to be here for the same information for 10 hours. You see what I mean?
Exactly. And I'd say you're nailing it, because usually I get into a space and I immediately get pissed off because it's so fluffy and going nowhere. But this feels very
Exactly.
very concentrated and directed. I like it. Keep it up.
Yeah, and it's going to get 10 times more concentrated. Thank you, Jordan. All right. Let's see if there's anything else we want to talk about. That's the only way you can scale. You know, when the stock goes up, we're going to have in here tens of thousands of people at once. Is Lord in here? Let's see. No, he's not here right now. Is Yutsi in here? If he can come up, maybe we can talk some 10Q stuff or macro a little bit. Wes, how is your search for the inputs going?
I hit a little snag because I don't know how big the Grok model is. I'm having to estimate that it's roughly similar to like a 70 billion parameter model. And when I see that, the unfortunately the data gets a little bit fuzzy because it doesn't look like throughput is very high at all. So I'm thinking it's probably not as lucrative as I initially thought.
Okay. I mean, that's probably why Elon's not super excited about it. The only time he talks about it is when somebody asks about it, you know?
I would think so as well. Yeah.
All right. Wes, did you see anything in Meta's, the company, earnings release, or Google's earnings release? Google just announced their first ever dividend. But
I
aside
saw the
from that,
dividend.
and so
Oh, you broke up there.
you saw what?
I saw the dividend announcement, which is why they're up substantially.
Anything else in terms of technology commentary from management?
No, I haven't seen any other details.
Okay. Looks like Facebook went down quite a bit due to their light revenue guidance. They actually opened much lower, and then they creeped up a little bit today and closed 10% before the earnings release. So these companies went up quite a bit. So minor correction is not the end of the world for these companies. And Nvidia is up 4% and 2% after hours. Google is up 12% after hours. So very big movements. This is an all-time high for Google.
What triggered this sudden interest or change towards these LFP batteries? Do you think it's the timing is just strictly cost effectiveness, or in preparation of mass production of the 25K, vehicles that are uh, expected to be produced? And because it seems like it's only specifically directed toward the Model 3 and Model Y. So is this sort of like a test period
Well, the
before mass
LFP
production?
batteries are already in Model 3 and Model Y. They've been there for years.
Is that just cost effectiveness, or is there some kind of shortage of the nickel? And is it absolutely confirmed that it does
Yeah,
not?
cost.
Okay.
Thank you. Wes, did you see Ron Barron interview?
Yeah, I did.
What did you think?
I loved how he said he thought the bottom was in. I thought that was neat. And he tried to go through and explain kind of how he saw things shaping up, for Tesla over the next few years. So, he still expects a huge gain, which I thought was fun to hear.
Yep. All right. And I don't see anything else on my radar to talk about today. So 3-hour space, very good, dense, information rich, and you all can go back and listen to it. Wes, thank you so much. And we can dig into those assumptions that go into inference compute, distributed inference compute, professional service later on when Meta is here too. I'm sure he would have some input into those as well.
Yeah, sounds good. Thanks, Ben.
All right, thanks. Take